All right, hi guys. I feel like I didn't maybe do a good enough job with the lesson, so I'm going to do one of each type of problem. Okay, so I'll do 2, 6, and 13. I think number 9 and that type is pretty clear. Okay, so I'm going to continue. I'm going to start with number 2. Okay, when does the particle change direction? Well, the particle changes direction when velocity changes sign. So whenever you're talking about a sign, then you need a sign chart. Put a title on it. We're looking for when is velocity going to change sign. And in order to do a sign chart, anytime you do a sign chart, you have to first find when velocity is 0. Well, this isn't even the velocity equation. This is the equation for position. So now I've got to find the velocity equation, which is negative 4t cubed plus 42t squared, because velocity is the derivative of position. Now I'm going to set that equal to 0 and factor at the same time. Now, I can factor out a 2 if I want to. You don't really have to, it won't matter. But if the first term is negative, you have to factor out that negative. So I'm going to take out a negative. The 2 won't matter either way, take it out or don't. And the t squared. And inside parentheses, I would have left a 2t plus 21. And then I'm going to set that equal to 0. Set each factor equal to 0, we get t equals 0, or 2t plus 21 equals 0. Solve that, and t equals... Did I miss a negative? I missed a negative. That was supposed to be right here. Whoopsies, that was supposed to be negative. Okay, so those were negative. I knew that because I was like, that's a suspicious answer. I was going to get a negative time. Add 21 and divide by 2, and t equals 21 over 2, or 10.5. Okay, so now on my sign chart, I know I have a t of 0 and a t of 10.5, or 21 over 2. Now, since this is time, remember that to the left of 0 doesn't really make sense. Okay, now we're going to be plugging in the values here and here to figure out whether our velocity is positive or negative. When you do that, you're going to plug it into this factored form of velocity. I'm going to rewrite it just so we can see it a little better. That's still velocity right there. It's just in the factored form of the velocity. Okay, you don't have to rewrite it though. All right, so now we're going to plug in a number here. If I plug in, say, 1. Well, when I plug in a 1, this guy right here, any number squared is positive, but then when I multiply it by a negative, no matter what I plug in for that, I'm going to get a negative answer. Plugging in the 1 to this factor, I would get another negative, and they are multiplied together. So a negative times a negative is a positive for all of these. So my velocity is positive for all of these numbers. Okay? Now do the same thing. Plug in a number to the right of 21 over 2, which is 10.5. So maybe plug in 11. Okay? Well, again, this guy is always going to be a negative. If I plug in 11 here, you get 22. That's a positive. And a negative times a positive is a negative. Now interpret the answer, because the AP graders will never look at a sign chart for the answer. That's for you to organize your work. You got to take the answer off of there for it to count. So if the question is, when does the particle change directions? It's when velocity changes signs, and the only place that happens is right here. T equals 21 over 2, or 10.5, and I think that was seconds. Okay, so there's number 2. All right, main thing that I think you could have gotten stuck on, if the first term is negative, before you factor, make sure you factor out that negative no matter what. Okay, and then don't forget to include it when you're doing your sign chart. All right, next I'm going to try number 6. Okay, number 6. This one asks you to find when the particle is moving left or right. Well, moving left means velocity negative, and moving right means velocity positive. And anytime we're looking for something positive or negative, we're comparing it to 0. You're looking at the sign. You need a sign chart. So make your velocity sign chart. Okay, so we need velocity first, and we don't have velocity. So do the derivative to get velocity. We get negative 3t squared plus 8t plus 60. Okay, now set it equal to 0 because we have to find when velocity is 0 first to do our sign chart. Okay, well, when I set it equal to 0, there's nothing I can factor out, but I still don't want this first term to be negative. So bare minimum, I have to take out that negative, which leaves a positive 3t squared minus 8t and minus 60. Okay. Now factor it again to get a 3t squared. I ignore the negative out front now. To get that 3t squared, it's 3t times t. And there's a couple of options for 60. It could be 6 and 10, 12 and 5. But remember, if there's no GCF here, don't bother putting anything here that's divisible by 3. So 10 and 6 maybe. Let me see. I don't want to put the 6 here because that's divisible by 3. I'm going to try the 10 and 6. My inners give me 10t. My outers give me 18t. I need that to be a negative 8. Sure, that works. Okay, if you don't like that method of factoring, then you can do your AC method, whatever. So I factored it. Now set each factor equal to 0. This factor, this guy here, set that equal to 0, you'd get a negative 10/3. Well, that's a negative time. That's garbage. Set this equal to 0, you get t equals 6. Okay, and don't forget there's a negative in front. So my current velocity equation in factored form is a negative, then I have 3t plus 10 and t minus 6. Now we're going to do our sign chart. On my sign chart, I have a negative 10/3 and a positive 6. But to the left of 10/3, that's all negative time. That's garbage. That doesn't exist in the world. In here is the 0 that I'm going to end up having to stop at. So you might want to make a note there's really a 0 in here. And you can't have anything to the left of 0 when it comes to time. All right, so plugging in one of the numbers in here, you could actually plug in the 0 because it's smack dab in the middle. Or if you weren't sure, maybe you can plug in a 1. But if I plug in either a 0 or a 1, then my velocity sign will be this negative right here is still there. This next factor, if I plug in either a 0 or a 1 or a 2 or any of those numbers in between there, that becomes a positive. And then this guy here, if I plug in a 0 or a 1 or any of those numbers, that's a negative. So remember, this negative out front still counts. So we have two negatives, which is a positive right here. All of that's positive. To the right of 6, I could do the same thing. I'm going to plug in a 7. And you don't have to show any work for this. You just do it. You can do it all in your head. When I plug in a 7, I have this negative. That counts as 1. So I'm plugging in a 7. This next guy would be positive, and this is a positive. So there's still one negative, which is a negative right here. So now let's use our sign chart to interpret our answers. Remember, the sign chart helps you organize your thoughts, but the AP graders do not look at that. All they're going to look at is your answer. You said moving left is when velocity is negative. So the particle's moving to the left from 6 to infinity. And not including the 6 because at 6 the velocity was 0 there. Particle's moving right when velocity is positive. And yes, that's from negative 10/3 all the way to 6, but there's no negative time. So we just say 0 to 6. And this is how you write your answer in interval notation. I think on the worksheet they said time is greater than 6, but it means the same thing. And this one, time is between 0 and 6. But now that I'm looking at this, I made a small mistake. At 0, that's definitely positive. So I should have used a bracket here, bracket there. Okay, moving on to one more, maybe number 13. Okay, this is probably the most time-consuming one because this is the one where they want you to know, where they want you to tell whether the particle is slowing down or speeding up. And that one requires two sign charts, velocity and acceleration. So you're going to do two sign charts, one for velocity, one for acceleration, and line them up one on top of each other, okay? And then remember, speed is increasing if velocity and acceleration have the same sign. Speed is decreasing if they have opposite signs. So we have to do a sign chart for both velocity and acceleration. Okay, velocity, let's get that equation. Negative 4t cubed plus 36t squared. Set it equal to 0 and factor. Always take out that negative. Negative 4t squared times t minus 9. So we get t equals 0 and 9. On my sign chart, that's when velocity is 0. To the left of 0 doesn't exist because there's no negative time. All right, change this back to, change this back to the title of velocity. This is my velocity equation, but it's velocity in factored form. Plugging in numbers between 0 and 9, I'll plug in 1. When I plug in a 1, this guy is always going to be negative because when you square, you get a positive, so I just have that negative every time. Plugging in a 1 right here, 1 minus 9 is negative 8, so that's another negative. 2 negatives make a positive for that one. Now plugging in something in this section, plugging in a 10, okay? If I plug in a 10, again, this is always negative. Plugging in a 10 right here, that's going to be positive, and a negative times a positive is a negative. Okay, now let's get acceleration in there. For acceleration, you want to go back to your velocity graph, go all the way back to here, and do the derivative one more time, because the acceleration is the second derivative. So, derivative of negative 4t cubed, that would be negative 12t squared, and the next one's positive 72t. Set it equal to 0 and factor. Always take out the negative, even if you can't take out the 12. Okay, so factoring, I'm definitely going to have to take out the negative and a t. You might have noticed that you can take out a negative 3. If you didn't notice it, it really doesn't matter. It will work out either way. And I'm left with a positive 4t and minus, that's 24. Oh, I could have taken out more than that. All right, well, this is proof that doesn't really matter if you take out the number part. Set each factor equal to 0. This one gives me t equals 0. This would give me, set that equal to 0, we'd get t equals 6. So I want to put the 0... I want to put the 0 and the 6 right in line with my velocity graph. So here's 0. The 6 would be here, just shy of that 9. Okay? And now we're going to do our acceleration sign chart. Again, left of 0 doesn't exist. Here's my acceleration that I'm plugging into. Okay, if I plug in a 1, I'm going to checking this section. Plugging in a 1. This would be negative. The other one would be negative. 2 negatives make a positive. Plugging in a 7, something to the right of 6. The first factor is negative again, and the next factor is positive, so that will be a negative. Okay, now to interpret it, you've got to merge these two sign charts, one on top of the other. Okay, so visualize the 6 cuts right here. Okay, so from 0 to 6, signs are the same. So between 0 and 6, if the signs are the same, we're speeding up. Okay. Then between 6 and 9, this one's still positive, this one's a negative. Signs are different, that's slowing down. So between 6 and 9, you're slowing down. Then after the 9, we have a negative and another negative. Signs are the same, speeding up again. So from 9 to infinity, you're speeding up. Okay, maybe you can find a neater way of merging these two sign charts. Good luck. Hope you're doing well.